Here's a practice problem. A solution is prepared by mixing 200 milliliters of 3.4 times 10 to the negative 5 molar lead-2 nitrate with 250 milliliters of 1.8 times 10 to the negative 6 sodium phosphate. The KSP for lead-2 phosphate is given. Will lead-2 phosphate form? So here's the idea. We'll take 250 milliliters of lead-2 nitrate at 3.4 times 10 to the negative 5th molar and add it with 250 milliliters of sodium phosphate at 1.8 times 10 to the negative 6 molar, thus producing a solution of 500 milliliters, and we want to know whether or not any lead-2 phosphate will form. Some solid on the bottom. Although in the question it asks for lead-2 phosphate, you should, remembering your solubility rules, recognize that lead-2 phosphate is the only possible solid that could form. Why? Because if nitrate were to combine with sodium, we would have a soluble compound, and the sodium and nitrate ions would remain in solution. You will notice that as you mix 250 milliliters with 250 milliliters, you get 500 milliliters. Thus, mixing these two solutions together, even before precipitate occurs, will dilute this concentration and this concentration. This will be a type of M1V1, M2V2 calculation, where the new volume is now 500 milliliters. So these two concentrations are going to be diluted when we mix them. We need to use the diluted concentrations in order to solve for Q to compare it to K. Remember that. We need to use the diluted concentrations. So the first thing that we'll do in order to solve for Q is we need to write, as I suggested, the KSP expression. It may be helpful, again, to remember your polyatomic ions so that you can correctly write the chemical formula for lead-2 phosphate. Having 3 leads for every 2 phosphates, thus we'll get 3 leads for every 2 phosphates, with a KSP expression of lead ion concentration raised to the 3rd power and phosphate concentration raised to the 2nd power. Q then is going to be these initial concentrations before any precipitate has formed, if precipitate will form, in order to get our Q. The initial concentrations then will be the concentrations that occur after mixing, after dilution. So it will not be these concentrations that are given in the problem. We need to solve for these initial concentrations, recognizing we start out with 250 milliliters, but we end up with 500. This is the concentration then of lead that we need to consider when solving for Q. And this will be the concentration of phosphate that we need to consider when solving for Q. After dilution has occurred, we can place these values then into the Q expression, calculate Q, and then compare it to our KSP. It turns out that because Q is greater than KSP, the reaction will shift to the left. This reaction will shift to the left, forming precipitate.